So I think my idea to have an antenna mount right there and then sneak the coax into the car is going to work. And the idea involves sneaking it under this weather stripping. So I removed this panel, the panel right here, so I can basically pull open this weather stripping, and it comes out very easily. So the idea is to basically run the coax through like that, but in particular, bury it and run it along the trough. So it's like trying to get it into the trough here. This is definitely difficult to do with one hand. And so it will run along the car a little bit to reduce the strain. So it's coming in there at this height. It's coming out actually at this height. So it's running along to reduce the strain. Obviously, I will tune it to look good, but I think it's gonna work. I have this multimeter set up in continuity detection mode. So if the two probes are electrically connected, it will make a beeping sound. I have one of the probes connected right here, and the wire leads back to the multimeter. And now I'm going to use this red probe to test if the 12-volt ground is connected to that point on the car up there. You hear the beep? They're connected electrically. So that point up there is a electrical ground inside the car. So I don't have any video footage for this part, but effectively what I'm doing here is modifying a K400C NMO mount from Diamond, which is their beefiest mount. Basically taking it apart and attaching it to the crossbar of the roof rack. So I start giving the roof rack a little tap with a punch to make it easy to drill into. And then I get in there with a oiled drill bit and kept raising the size of the bit until the hole was the appropriate size for the bolt that I'd be lacing through there. I did that with a Metmo driver, which is a great piece of engineering art from England. I then connected the grounding strap up, and there's actually a problem with this that we'll see later on. Bolted that mount to the roof rack, laced the coax and strap through the trough, put that rubber back over the trough, added some heat shrink tubing around the part of the grounding strap that will inevitably be in contact with the car, and used the heat gun to shrink it. You can see the multimeter in the background there. That this just did not work well, even though I checked the continuity of the grounding strap at this point, and you can see it all shrunk up now and ready to go. So I got it on the car, sort of. This will look better. I'm gonna get it more lined up. It's actually going in the car. See, that goes there, and it pops out right there. The ground is going to attach right there, and this heat shrink is to prevent abrasion on the paint. So I'm working on affixing the grounding strap mechanically to the car and then bonding it at the point where this door latches. And I've already established that these points here are electrically connected to the 12-volt ground system of the car. So basically I'm just using this 3M product, which is a double-sided automotive tape, and sticking it to the car in an appropriate way using the tape, routing it to there, and then I will bolt it all up. So I'm training this braid to go around these bolts. So I initially went in with this tool and just basically kind of pried apart a hole, and then shoved the bolts all the way through, and I'm getting this positioned roughly correctly to seal it all back up. I'm going to smear some of this dielectric grease all around this area before sealing it all up. So this is what the grounding strap project looks like. A phase of the project looks like when it's complete. It's going back in there. Very solid. We've got dielectric grease in there too. And I'll be testing this shortly with a multimeter, confirming proper operation. So I actually had a problem with the ground, and I think it was due to oxidation. Like this point was no longer connected to the braid electrically, or it was, but by like several hundred ohms, which is not really what we're going for. So I basically opened this, opened that back up and put another piece of braid in that goes around here, put dielectric grease everywhere in there, put dielectric grease everywhere in there, did a little bit of sanding as well of the metal in there, and then hooked it all back up, and right now it's measuring fine. So I'm going to keep an eye on it, but I think I've fixed it. So I then proceeded to mount a Diamond SG7900A NMO securely onto the mount. It's a 62.2 inch tall antenna with 5 dB of gain on the 2 meter band and 7.6 dB of gain on the 70 centimeter band. The thing that's especially interesting about it is that this antenna does not require a ground plane to function optimally. So the fact that the antenna is on a mount that is attached to a crossbar should not matter because of this, because of how the antenna is designed and phased, and does not require a ground plane. Looks good on the car. The 2 meter band SWR looks excellent. The 70 centimeter band SWR looks okay. I can tell you it definitely performs, although I really want to cross-reference the low end of the band with repeater inputs and stuff like that. I haven't done that yet, but it definitely functions well according to my actual usage, and it does look great on the car. So this is parking garage mode of this antenna, and I'm going to be researching exactly what will fit here. Supposedly the garage has 6 feet 8 inches of clearance. This is what the install looks like with the tri-band compact antenna. I believe it's 7.5 inches tall, and this fits into parking garages fine, in particular the garage that I park in. So here the compact antenna mounted is in the parking garage I park in when I'm at the office. That has a 6 feet 8 inch clearance, and this fits fine, a couple inches to spare. This antenna is tri-band 2 meter, 220, 440, made in the USA, 7.5 inches tall, and it performs remarkably well. I have a lot of experience using this antenna, both in this configuration as well as with a mag mount on the corner of the car roof, and it performs remarkably well. The 2 meter SWR looks great, and like the SG7900, the 70 centimeter SWR does not look ideal on the low end of the band in particular. And at this point I'm just realizing now that I really should go and check like the feed lines and try to do some optimization around this potentially. But in terms of actual real world performance, this antenna performs remarkably well on the 70 centimeter band. There's a System Fusion repeater in Gloucester, Massachusetts, W1GLO, that's on a nice big tower, and I can reach that repeater and hear that repeater with a perfect signal from Revere, Massachusetts. And Gloucester and Revere are not particularly close together, so empirically it does work great. I don't really like the way the SWR looks. So if anyone has any ideas about what I might do about the 70 centimeter SWRs I'm seeing, please reach out. This was a very fun project to work on, and I hope this gives people some ideas about how to add an antenna to a car without drilling holes in the roof and whatnot, and some ideas in particular about the Volkswagen, because there wasn't a ton of info about Volkswagens in particular. Anyway, I hope you enjoyed it. I certainly did. Thank you.